Hello everyone. So kule video sidiscussa ama questions with trigonometry from Maths paper 2 November 2011. Sizokwenza question 12. Right? So question 12 12.1, but he proved that if cos alpha minus x is not equals to 0, the left hand side should be equals to 1. Prove that this fraction is equals to 1 when cos alpha minus x is equals to 0. Right? So sizothoma ngokuthi the left hand side is equals to sine x plus 450 degrees minus alpha divided by cos alpha minus x. And then must rearrange lapha ku numerator yethu sizoba no sine x minus alpha plus 450 degrees. Sine x minus alpha plus 450 degrees divided by nala good denominator se rearrange. Another way of writing alpha minus x is saying minus x minus alpha, right? So if you have minus x minus alpha, if you have minus x minus alpha, and then you multiply out the brackets, uzoba no minus x plus alpha, which is alpha minus x, right? So lapha ku denominator sizorearrange and write cos alpha minus x as cos minus x minus alpha, right? And then kumbuluti, if you have cos theta, if you have cos minus theta, this is equals to cos theta, right? So lapha ku denominator yethu sizoba no, okay, numerator still no sine x minus alpha plus 450 degrees, and then good denominator sizoba no, because cos minus theta is equals to cos theta, it means that cos minus x minus alpha is just equals to cos x minus alpha. Okay, so now sino cos x minus alpha. So now ku numerator yethu sizosebenzisa i-identity from formula sheet yethu. So if we have a formula sheet, you can see lapha ukuthi sine alpha plus beta is equals to sine alpha plus beta is equals to sine alpha cos beta plus cos alpha sine beta, right? And then if we do the same lapha ku numerator, we have treat sine x minus alpha as a unit, right? And then lapha sizo apply this identity city sine a plus b is equals to sine a cos b plus cos a sine b, right? So now apply this identity ku numerator yako, uzoba no sine x minus alpha cos 450 degrees plus cos x minus alpha sine 450 degrees, right? And then numerator yakho you still have cos x minus alpha, right? So now if we have a calculator yakho, you would see ukuthi cos 450 degrees is equals to 0 and sine 450 degrees is equals to 1. So now uzoba no sine x minus alpha times 0, because cos 450 degrees is 0, and then lapha uzoba no cos x minus alpha times 1, because sine 450 degrees is 1 divided by cos x minus alpha, right? Therefore our numerator would be equals to cos x minus alpha, and then we divide by cos x minus alpha, which is equals to 1. Therefore the left hand side is equals to the right hand side. Okay, that is how you solve this question. So ama steps abalulekile lana ilas apply khona i-identity le yaka sine a plus b, and then esinye step rearrange, and then noting ukuthi cos of a negative angle is cos of that angle, right? Yeah. Okay, now going to question 2. So question 2, determine the general solution of cos 2x equals to 1 minus cos x. First things first, says what we should write this is in standard form, right? We want to have this equation equals to 0 somehow, right? So sizoba no cos 2x minus it's plus 3 cos 3 cos x. Okay, let us do this. So we have cos 2x is equals to 1 minus 3 cos x, right? Remember what this is, cos 2x can be written as cos squared x minus sine squared x, or 1 minus 2 sine squared x, or 2 cos squared x minus 1, right? So kumele choose from from these three ukuthi uzokureplace cos 2x ngayiphi, right? Because kule equation I don't have the trigonometric ratio yaka sine, I wouldn't choose the identity eno sine, so I would choose the one with cos only, ne? So I will choose the third one, right? Because angifuni ukuthi ngidile no sine and then delay no cos. At the same time, I want to deal with cos only, right? So this one for cos 2x in Zobala, the dead identity. So Zobano 2 cos squared x minus 1 is equals to 1 minus 3 cos x, right? And then we write this in standard forms is over no cos squared x minus, okay, split to minus 3 cos x this side, this is over no 3 cos x minus later minus 1 lower this side is over no minus 2 equals to 0. Okay? And then now we have a quadratic equation. We can now solve for cos x. So solving for cos x, we can factorize by saying this equation is equals to open brackets 2 cos x minus 1 times cos x plus 2 when you factorize this equation, right? So remember this is a quadratic equation, so it's in this form, so it's just 2x squared plus 3x minus 2 equals to 0. The way you would solve this quadratic equation, in place of x lapatina we have cos x, so it is just a normal quadratic equation, but then we want to solve for cos x in our equation. So now solving for cos x, we see cos x is equals to 1 over 2, or cos x is equals to minus 2, right? So from this we see x equals to cos inverse of minus 2. If you press this in a calculator, you would see we don't have any solution here, right? And then for this one, if you say x cos inverse of minus 1 over 2, you would get 60 degrees, right? And then that is our reference angle. So we are more interested on this one now, because this one, it doesn't have any solution, right? So we want the value of x where cos x will be equals to 1 over 2. So we want an angle such that if we take cos of that angle, we will get 1 over 2, right? Because we want a positive number, which is 1 over 2. Remember from your cast diagram that in the first quadrant, all the ratios are positive, second quadrant only sine, third quadrant only tan, and then the fourth quadrant only cos is positive. So we want the angle in the quadrants where cos is positive, right? Cos is positive in the first quadrant and in the fourth quadrant, right? So in the first quadrant, we can just have our solution as x being equals to 60 degrees plus k 360, where k is the element of the integers, right? And then in the third quadrant, we can have a negative angle, or we can have 360 minus the positive angle, right? So in the third quadrant, for the negative angle, so the one of x is equals to minus 60 degrees plus k 360, right? Where k is the element of the integers. Or we can have 360 minus the positive reference angle. So if you say 360 minus 60, you'll have 300 degrees, and then you would say plus k 360, where k is the element of the integers. So this is our general solution. Okay, now going on to question 3. Question 3 bathini. Okay, so question 3 but prove that for angles A and B, the left hand side is equals to the right hand side, right? So now the left hand side is equals to sine A over sine B minus cos A over cos B, right? So now if we find the common denominator, sizoba no sine A cos B minus cos A sine B divided by sine B cos B, right? And then if you go to your formula sheet and look at sine A minus B, you would see that is sine A cos B minus cos A sine B. Notice nati in our numerator we have sine A cos B, which is this part here, and then we have cos A minus cos A sine B, which is this second part here. So we can write the numerator as sine A minus B. Right? Using that identity, our numerator will be sine A minus B, right, divided by sine B cos B, right? And then if you multiply the numerator and the denominator by 2, you would see 2 sine A minus B divided by 2 sine B cos B is the same as this, right? Remember, 2 over 2 is just 1, so ngamanye amagama we are multiplying by 1, right? And then notice from this identity here, sine 2A is equals to 2 sine A cos A, right? Tina lapha ku denominator we have 2 sine B cos B. Therefore, our denominator will be sine 2B. And then we are done because sisebenzise this identity, right? Now moving on to question 3. Question 12.3.2. But hence or otherwise, without using a calculator, show that the left hand side is equals to the right hand side, right? So if but hence, they mean that you can use what you have solved already, and then or otherwise it means you can use other ways of solving this, right? So we now would go for the hence part, because already seen our clues from previous questions, right? And then Lanabati show that the left hand side is equals to the right hand side. Notice the left hand side lagu question A is similar to the left hand side to 12.3.1. So if you take the hence approach and use this equation here to sort of like replicate 12.3.1 in question A, the left hand side of 12.3.1 is similar to the left hand side of this equation. Lapa you have sine 5b over, now you have sine 5b over b, lapa you have sine A over sine b. Lana, and then you minus pi cos 5b over cos b, lapa you have cos A over cos b. So notice in place of A, now we have 5b. In place of A, instead of saying sine A, it is sine 5b. And then instead of saying cos A, it cos 5b, right? And then it means that A is equals to 5b in this question, right? So if we take the hands approach, so if we take the hands approach, sizoti okay, from the previous question, in place of A we have 5B. So sizoti from 12.3.1 in place of A, from 12.3.1, A is equals to 5B. Sorry, A is equals to 5B, right? And then it means that because we have showed or this combisile already, the left hand side is equals to this, it means we can rewrite the left hand side as, we can rewrite as 2 sine 5B minus B, right? Because in place of A we have 5B, right? Divided by sine 2B, right? And then 5B minus B is just 4, so numerator will have sine 4B. We will have sine 4B divided by sine 2B. And then 2 sine 4B we can rewrite as saying sine 2 times 2B, right? 2 times 2B is just 4B, right? Divided by sine 2B. Okay. So now we have sine 2B. Remember that if you have sine 2A, this will be 2 times sine A cos A, right? From the identity Lego formula sheet. But then we have 2 times sine, we have sine 2 times 2B. So in place of A, Lapatina, we have 2B, right? So it means we will rewrite the question. So in place of A, we have 2B. So we have sine 2 times 2B. In place of A, we have 2B. So in place of A, we have 2B. So this will be equals to 2 sine 2B cos 2B, because in place of A we have 2B. So our numerator is over now 2 times 2 sine 2B times cos 2B divided by sine 2B. Now this one and this one we will cancel, and then we will have 2 times 2, which is 4, and then we will remain with our cos 2B, right? Therefore this is equal to the right hand side. So we have proved this, right? Now going on to the next question, 12 point, let's see, question B. Okay. And what he hence or otherwise show that 1 over sine 18 degrees is equals to 4 times cos 36 degrees. Now notice what this right hand side is similar to the right hand side from the previous question. So question A lapha we have 4 cos 2p, now we have 4 cos 36, right? So notice ukuthi 4 cos 36 is equals to 4 cos 36 is equals to 4 cos 2 times 18 degrees, right? So there, in place of B, we have 18 degrees. So from question A, B is equals to 18 degrees, right? Therefore, the right hand side is equals to 4 cos 2 times 18 degrees, right? We know from question A that 4 cos 2p is equals to this one, right? But then we have shown what this is the same as saying 2 sine A minus B divided by 2 sine 2p, right? These questions are connected, right? So 4 cos 2p should be somehow related to this one here. So from question okay, so this will be equals to 2 times sine 5 times 18 degrees minus 18 degrees divided by sine 2 times 18 degrees, right? From question A and question 12.3.1, because CTUP is equals to 18 degrees, right? Now this will be equals to, we know what from your calculator, if you say 5 times 18, you will get 90 degrees. So this will be equals to 2 times sine 90 degrees minus 18 divided by, now sine 2a is equals to 2 sine A cos A, right? In place of 8, now we have 18, so this will be 2 sine 18 degrees cos 18 degrees, right? That 2 and that 2 will cancel. We will remain with sine 90 degrees minus 18 divided by sine 18 cos 18, right? But then, since sine 90 minus is the cofunction of cos, so sine number reduction formula, we know what is sine 90 degrees minus theta is equals to cos theta. Okay? So sine 90 degrees minus 18 is equals to cos 18, right? So in the denominator we have sine 18 cos 18. This cos and that cos will cancel, so this will be 1 over sine 18 degrees, which is equals to the left hand side. Okay, so we have proved that the left hand side and the right hand side are equal, right? Now I believe the tricky one is question C. Labo question C, but show that sine 18 degrees is a solution of the cubic equation. So now tell this cubic equation, it could seem ukuthi kungabonakala ngathi sine 18 degrees is not in any way related to this equation, but then let us solve it. Right, they want us to show that sine 18 is a solution of this cubic equation. So to show that something is a solution to an equation, it means that if you substitute that something in that equation, it should satisfy the equation, right? So now if we let sine 18 degrees be equals to x, then from question B we showed ukuthi sine 1 over 18 degrees is equals to 4 cos 36 degrees, which is the same as saying cos 2 times 18 degrees, right? So this is the same as saying, because sine 18 is x, this will be 1 over x no, sine 18 is x, but then here we will use the identity saying cos 2x is the same as saying 1 minus this identity, right? So now in place of x we have 18 upper, so we have 4 times 1 minus 2 sine squared 18 degrees, right? And then because ct sine 18 degrees is equals to x, we will have 1 over x equals to 4 times 1 minus 2 x squared, right? And then cross multiplying, okay, we have 1 over x equals to 4 minus 8x squared, and then cross multiplying, we'll have 1 equals to 4x minus 8x cubed, and then rearranging you can get to this equation. Therefore sine 18 satisfies this equation, right? Because x is equals to, let x be sine 18 degrees. So sine 18 degrees is a solution to this cubic equation, right? Therefore sine 18 degrees is a solution, and then you are done.